Mendeleev's periodic table. Before we learn about the Mendeleev's periodic table, let us learn about the earlier attempts on the classification of elements. British chemist John Dalton gave the basic theory related to the nature of matter, named as Dalton's atomic theory. He had taken the name atom as given by the Greeks. He proposed that atoms are the smallest particles of matter. According to Dalton's atomic theory, it was believed that all matter is composed of small particles called atoms. Atoms of a given element are identical, both in atomic weight and chemical properties. Different elements have different types of atoms. Atoms of different elements have different atomic weights and chemical properties. In 1789, Antoine Lavoisier became the first scientist to classify substances, including light and heat, into metals and non-metals. His classification, however, was unsuccessful because his table consisted of many wrong information. For example, light, heat, and a few compounds that were unable to decompose into elements at that time, such as lime, silica, alumina, baryta, and magnesia, were considered as elements in his table. In 1829, German chemist Johann Wolfgang Dobryner divided the elements into groups of 3 with similar chemical properties, known as Dobryner's law of triads. It states that when a group of 3 elements are arranged in increasing order of atomic masses, the atomic mass of the middle element was approximately the average atomic mass of the other 2 elements in each triad. Also, the properties of the middle element were in between those of the other 2 elements. This classification led chemists to realize that there was a relationship between the chemical properties and the atomic mass of each element. Let us take 3 elements, lithium, sodium, and potassium, that created a Dobryner triad. The atomic masses of these 3 elements are 7, 23, and 39 respectively. In this case, the arithmetic mean of the atomic masses of the first element, lithium, of the triad and that of the third element, potassium, is found equal to atomic mass of the middle element, sodium. Atomic mass of sodium is equal to 7 plus 39 upon 2, which is equal to 23. You can see that actual atomic mass of sodium is also 23. Atomic masses of chlorine, bromine, and iodine are 35.5, 80, and 127 respectively. If we calculate arithmetic mean of the atomic masses of first and third element of the triad, that is 35.5 plus 127 upon 2, it comes out to be 80. This value is approximately equal to the atomic mass of the middle element bromine. Similarly, observations can be made out about other triads such as calcium, strontium, barium. This triad belonged to alkaline earth metals. If these elements are arranged in order of increasing atomic masses, calcium, that is Ca, comes first, followed by strontium, denoted by Sr, and barium, that is Ba. Strontium, as the middle element, should have atomic mass, which is the average of atomic masses of calcium and barium. Atomic mass of strontium is equal to atomic mass of calcium plus atomic mass of barium upon 2, which is equal to 40 plus 137 divided by 2, which further equals to 177 upon 2, which equals to 88.5. This value is close to the actual atomic mass, which is 88. Let us now learn about drawbacks of Dobryna's triads. A large number of elements showing similar properties could not be grouped into triads. Examples of these types of elements are iron, manganese, nickel, cobalt, zinc, and copper. It was possible that quite dissimilar elements could be grouped into triads. Dobryna could only classify 3 triads successfully. Since he failed to arrange all elements then known in the form of triads. From 1864 to 1865, John Newlands arranged the known elements in order of increasing atomic masses. Elements with similar properties recurred at every 8th element. This was known as the law of octaves. This means that fluorine, denoted by F, had the properties similar to the first element, hydrogen, denoted by H. Likewise, 9th element had the properties similar to that of the second element. He placed the 9th element, sodium, denoted by Na, below the second element, lithium, denoted by Li. Similarly, 10th element, magnesium, that is Mg, was placed below beryllium, that is the third element, and so on. The 16th element, potassium, that is K, again had properties similar with those of lithium and sodium. To explain this concept, periodicity was introduced. He correlated the similarity in the properties of every 8 elements to notes of music. Every 8th note is similar as the first note. Newland checked the properties of the groups so formed and found that his law was applicable up to calcium, but it failed in the subsequent elements. However, John Newlands was the first chemist to show the existence of a periodic pattern for the properties of elements. In 1869, Lothar Meyer, a German chemist, studied the physical properties of various elements and stated that the graph plotted between atomic volumes and atomic weights of the elements show that the elements with similar properties occupied similar positions on the curve. Atomic masses were taken on x-axis, whereas atomic volumes were taken on y-axis. Let us have a look at the observations. The most electropositive alkali metals like sodium, potassium, and rubidium occupy the top position on the curve. The less electropositive alkaline metals like beryllium, magnesium, and calcium occupy the descending positions on the curve. The electronegative elements like chlorine and bromine occupy the ascending position on the curve. On the basis of this observation, Lothamer proposed that physical properties are the periodic function of their atomic weights. Dmitry Ivanovich Mendeleev was a Russian chemist born on February 7, 1834 in Tobolsk, Russia. He studied physics, mathematics and chemistry at the Pedagogical Institute in Moscow. For some time, he worked in a school as a natural sciences teacher. In 1869, Mendeleev arranged the elements in order of increasing atomic mass and grouped them according to the similar chemical properties. He left gaps in the table to be filled by undiscovered elements. He was able to predict the properties of undiscovered elements. A periodic table may be defined as an arrangement or chart which classifies all the known elements on the basis of their properties in such a way that the elements with the similar properties are placed in the same vertical column and dissimilar elements are separated from one another. The main credit for classifying elements goes to Dmitry Ivanovich Mendeleev, a Russian chemist. He was the most important contributor to the early development of a periodic table of elements. He tried to correlate the atomic masses of the elements with their physical and chemical properties. He selected hydrogen and oxygen as they were very reactive and formed compounds with most elements. The formulae of the hydrides and oxides formed by an element were treated as one of the basic properties of an element for its classification. He concluded a law known as Mendeleev's periodic law, which states that the physical and chemical properties of elements are a periodic function of their atomic masses. This means that the properties of elements get repeated after certain regular intervals. In other words, it may be stated as when elements are arranged in order of their increasing atomic masses, elements with similar properties are repeated after certain regular intervals. This repetition of properties of elements after regular intervals is called periodicity of properties. At the time when Mendeleev gave his periodic table, only 63 elements were known. He then took 63 cards and on each card he wrote down the properties of one element. He sorted out the elements with similar properties and pinned the cards together on a wall. he compiled as much information as he could about each element. Then he put down the names and the properties of each element on a separate card and tried to arrange the cards so as to find a connection between the elements. While arranging the elements in groups and periods, he laid more stress on similar properties and made certain adjustments in their atomic masses. The element argon with atomic mass 39.9 was placed before potassium having atomic mass 39.1. He noticed that there was a regular pattern in the properties of the elements arranged in order of their increasing atomic masses. Mendeleev called the regularity as law of periodicity. He lined the elements up in rows of increasing atomic masses. A new row was started when the next element showed properties similar to the elements in the previous row. What he obtained was a table in which columns contained elements with similar properties. He also left gaps in the table for certain elements not known at that time. But he could predict their properties from the properties of the preceding elements present in the same groups that were known at that time. In order to identify them, he put the prefix eka before the name of the element. Eka in Sanskrit means one. For example, scandium, that is Sc, gallium, that is Ga, and germanium, that is Ge, were not a part of the Mendeleev's periodic table and were discovered later. Scandium was named Eka boron, which means that there was a gap left after boron in the periodic table. The properties of Eka boron were similar to those of boron. This helped a lot in the discovery of scandium. Similarly, gallium was named as Eka aluminium and germanium as Eka silicon. This means that these two elements fill the gaps after aluminium and silicon in their respective groups and had properties similar to these elements. The original periodic table was published in a German journal in 1872. Characteristics, features of the Mendeleev's periodic table. Mendeleev's periodic table consists of 7 horizontal columns called periods, numbered from 1 to 7. Eight vertical columns are called groups. These are designated as 1, 2, 3, 4, 5, 6, 7, and 8. Except group 8, each group is subdivided into 2 groups designated as A and B. Elements which are on the left-hand side of each group constitute subgroup A. They are called normal or representative elements. The elements which lie on the right-hand side of each group constitute subgroup B. These are called transition elements. This division is made on basis of properties. Group 8 contains 9 transition elements in 3 sets, each containing 3 elements. These 3 sets lie in 4th, 5th and 6th period. The noble gases were not known at the time of Mendeleev. So, no group of noble gases existed in Mendeleev's original periodic table. However, when these gases were discovered around 1900, a new group called the zero group was added to the Mendeleev's periodic table.